Hi and welcome to Lecture 3. In this lecture we'll talk about migrations, incentives for migrations, and how migrations work. So your typical application, whether it's a Rails application or Java application, is always going to be agile. Things are always going to be changing. The only constant thing about software requirements nowadays, or anytime, is that they are always changing. But how do we monitor and undo the changes to the database? So we could always just do it manually and add a column here and remove a column here and write a script for doing so, but this is going to be messy and error prone. The other issue with SQL in general is that typically SQL is used to create and modify tables for a particular relational database. So the dialect is going to be somewhat different, and it seems intuitive to actually use a specific dialect of a database that you're working with. But what happens if you want to switch database engines in the middle? So for example, you want to start developing an SQLite and then eventually deploy your application to Postgres, or maybe be working with MySQL and then switch to Postgres, or the other way around. So to avoid the two issues that I just mentioned, number one, the issue of agility and things constantly changing, as well as locking yourself into a specific SQL dialect, the way Rails or Active Record handles database changes is through this thing called migrations. And basically what migrations are, they are just Ruby classes that extend a certain base class, Active Record Migration, and basically it ends up being a file that has to start with a timestamp, where the timestamp is year, month, date, hour, minute, second, and it's followed by a certain name of that migration, and that becomes the name of a class, of a Ruby class. And then the timestamp defines the sequence and how that migration is applied to a database, and it sort of acts as a database version of sorts. So for example, when we created our resource, our entity cars, the following migration was created by the scaffold command. And just to orient yourself, the fancy cars is the top level directory. Then we have your app directory, and inside the DB directory, where by the way the SQLite, the actual database is stored, you're also going to have a migrate folder, which has the actual migration. And the first part of it is going to be the timestamp, so the year, month, and so on. And then the second part is called create underscore cars. So this is your class, create cars, which extends the migration superclass. And basically it just has one method called change, which says create table, and this is your migration. And the timestamp of this migration is the first part of a file name. Now you can create migrations by hand, but it's obviously much less error prone to use a generator like we did by doing the scaffolding. And if you already have the database set up and you don't need to create a migration, you could just specify a no migration flag to your scaffolding. Now there's also, besides creating a migration as part of a scaffolding, as we're going to see, there's also an explicit migration generator, which we'll get to. Now, once you generate a migration, once you create a migration Ruby class, you have to apply it to a database to migrate the database to its new state. So when you create a migration, again, just to recap, you're creating a Ruby class, and then you do rake db migrate, which actually updates the database by applying the contents of that class. Now, no two migrations can have the same class name, and when you run the rake db migrate, you apply all the migrations that less than the timestamp of your last migration. And migration maintains the table, a database table called schema migrations. If you remember way back, we saw that the database currently has two tables. One is called cars, and one is called schema migrations. And the schema migrations table actually just has one column called version. And that version column maintains the version of the last migration that was applied to your code. And once the migration is applied, the version is stored in that schema migrations table. So what this means is that if you run rake db migrate more than once, nothing is going to happen the second time because your database inside the schema migrations table already has the version column, and it's going to show that the latest migration has already been applied, so nothing is going to happen to your database. So what actually goes inside the Active Record migration subclass, which is your migration code? Well, you could either have the up and down methods, in which in the up method you generate the schema changes. So for example, create a table. And then your down method would have the way to go back out of it. So you could roll back your migration. So if the up method would have create the table, your down method would have undo the changes. So you would have the command destroy the table. But more often than not, you're just going to have one method in your migration class called change. And usually Rails is pretty good about guessing how to undo the changes that you made. So for example, if in your change method you're going to have create a table or create a column, and then you want to roll back out of that state back to your previous state, and you do rake db rollback, Rails will know how to unapply the change that you made by looking in your change method. And migration also gives you database independence, because instead of specifying a specific database type for a particular database type, migration lets you specify a logical database type. And then you have the Ruby adapter, database adapter, which translates that particular Ruby code to your specific dialect. So you'll have a MySQL adapter, or Postgres adapter, or SQLite adapter, and what they do is they translate the Ruby code that you write to a specific dialect of your database. So you specify logical database types, and they get converted to specific physical database types. So for MySQL, it will end up being one type, Postgres another, and so on. So here's the actual mapping of types. So in your migration type, you just specify these types: binary, boolean, or string, or integer, and they might end up being these different types in whichever different database engines you're using, but you don't really care. And the benefit of this is that, let's say you're developing an SQLite and you're using the logical type, and then you want to maybe switch to Postgres, you could do that easily because you haven't really tied yourself down to a specific database engine. Now, you could also specify certain column options. So for example, you could specify a null constraint if your database actually supports it. So you could say, can this column be null or not? So null, and it's just a symbol. So it's a hash with a symbol and a value. So null, true or false. When false and not null constraint is added. Or you could specify a limit. For example, this is a string field, and you want to specify a size. You want to set a limit on the size of a field, so you could do that by doing the limit size, whatever that size is. For example, limit : 5. That your string in the database should not be more than 5 characters. And you could also do a default value. So for example, when something is created, you want to specify that the value should always be 5 when in the beginning. Now, this only gets calculated once when you actually run your migration. So even though the code is a Ruby code, so you might think, for example, if you specify a date, then that means that anytime you create a new record, and add it to that table, it's going to calculate a new date. That's not what's happening. The migration is only a way to tell to tell the database what value to use initially. So then if whatever, let's say you're specifying a default value of today, this value will only be calculated when you actually apply the migration. So the default value will always be whatever value that you used when you actually apply the migration, not every time a record is calculated, a record is added to the database in the future. More column options that you could specify in your Ruby class migration. If a column is a decimal value column, you could specify a precision, which precision says how many total number of digits can you store. And there's also a scale value, which basically says where to put the decimal point. So for example, if you specify a precision of 5 and a scale of 2, you could store any range of numbers between 999, well, negative 999.99 to positive 999.99. In summary, migrations are just Ruby classes that get translated into DB speak, and the table in the database keeps track of which migration was applied last, and this way you could do rake db migrate to go forward and rake db rollback to roll back your migration. What's next? Next we'll take a look at the actual creation and altering tables and columns. This lecture was more theoretical about how migrations work in general. In the next lecture, I hope that you'll get to see how migrations are actually written and applied a little more.